Hello everyone, this is KP the Math G. Well, I guess you were thinking I wasn't going to do another video. Well, I'm going to do as many as I can. I've been kind of busy outside getting a couple of gardens ready. They're small gardens, but yet they're big enough to put a lot of labor into it. Got a few raised beds and got a couple of greenhouses, though not huge, but still they do the job. So having a lot to tend to here recently. Alright, well anyway, let's go ahead and get started. We are dealing with 2009 free response question 2. I do have the 2009 free response. I want to say that is question number 3. I have this one is, I don't know what question number it really is, but I was looking for it. It was question 4, so I'm going to do that one as well, but not in the same video. But I do want you to be familiar with the language of this. Let's look at this problem here very carefully. I have stuff falling off my desk, but that's okay. Let's pick it up now. Alright, there we go. It's crowded here, believe me. I try to keep things in order, but it still gets a little crowded. It says the rate at which people enter an auditorium for a rock concert is modeled by the function r, given by r at t is equal to 1380 t squared minus 675 t cubed, where t is between 0 and 2 hours. So what we're going to do is we're going to just kind of skip over A and B. If we have time, we'll come back to those, but that may be a different lesson altogether. I have done similar lessons on A and B before, so I just want to kind of go into C and D. Very important to understand those as well. That says the total wait time for all the people in the auditorium is found by adding the time each person waits, starting at the time the person enters the auditorium and ending when the concert begins. The function W, right? The function W models the total wait time, and that's what I said, total wait time for all people in the auditorium is W. That is the total wait time. Okay. The function W models the total wait time for all the people who enter the auditorium before time t. The derivative of W is given by W prime at t, which is 2 minus t times r at t, but r at t is this. Okay. So find W2 minus W1, the total wait time after t is 1. What they're doing here, and that's what I want you to be able to distinguish or to discover, is that the wait time is W, so they give the derivative of this. So it does say find the total wait time, so we have to get back to W. So how do we use this to get back to W, which is the total wait time? Okay, here's your total wait time right here. It is W, but you have W prime. Okay, so how do you do that? Yeah, you have to take the antiderivative of W prime at t dt. Now, if we're going from 1 to 2, then this actually means W at 2 minus W at 1. Okay, and that's what that really is. So it does say find this. All right, well, that's equal to the integral from 1 to 2. Now look at this. W prime at t dt is equal to this. So it is 2 minus t, all right, r at t dt. So we're going to go ahead and put all of that. So 1380 t squared minus 675. All right, running out of room here. T cubed, and we're going to squeeze somewhere down here a dt right here. All right, that's really what you are looking for. Probably the best way to do this, I mean, you can multiply this out by hand, or you can use your calculator, and I do have mine on right here. I have it on my phone actually, so let me look it up on my phone, and let's see if I can find it. I've already did the answer. Hopefully it's still there, and it is there. Yes, it is. It is there. All right, so that is from 1 to 2. All right, so that is 387. I get 387.5. All right, so 300, which is equal to 387. Make that 3 look a little more presentable. 387.5. Now it says total wait time. Time is in hours. Yes, it is hours right here. So hours. You do need to put your units down. There it is. This is just simply a to see if you understand the idea behind the fundamental theorem of the calculus. You remember there are 2 parts to this, and this is actually one of the 2. You can call this part A or part B or part 1 or part 2, depending on which one is in your book first, but it does not matter. This means, right here, this means W2 minus W1, and that's what you were supposed to find, and that is equal to the, well, if we're going to integrate this side, we're integrating this side from 1 to 2, 2 minus t, r at t. You could probably get away with r at t dt if you put it up here, what r at t is, okay? Then you could just simply put r at t dt, put it in your calculator, 387.5 hours. So that's the idea behind this, is that when you see what total wait time is, it is W, but they give you the derivative on purpose so that when you take the antiderivative of it, or the definite integral of that, then you will see that's what you're looking for. You want to go from 1 to 2, not from 0 to 2. Okay, so after t equals 1. Alright, so there it is right there, 387.5 hours. That's everybody waiting. How much total wait time is that? Okay. Alright, and actually, really, you think, so 2 hours is the max per person, because that's what it is here. Alright, so anyway, there it is. Alright. and not everybody's going to wait 2 full hours because not everybody's going to be in the auditorium at the same time. Okay, so there you go. That is a summation of all the total wait times for each individual. So I hope that helps you understand what you just found. Okay? Alright, let's look at this on the other side. Well, let me see if I can flip this over. This is actually part D. On average, how long does a person wait in the auditorium for the concert to begin? We are to use that integral again, but now this time we are going from 0 to 2, not from 1 to 2 this time, and it is w prime at t dt, which by the way is from 0 to 2. Well, I just have to look at the problem again, and that was 2 minus x, alright, t if you wish, okay, times r at t, which was, I'm going to go ahead and put the whole thing down, 1380 t squared minus 675 t cubed, all dt right here. Alright, like that. That's what we're doing. We're going from 0 to 2 this time. But since it says on average, I need to average this. So I'm dividing by the total if you want to. And there are, in problem 1, there are 980 people. So you can simply divide by 980 like that. Okay, there it is. Or if you want to, you can put this 1 over 980 in front of this. Either way, that's average. That's what you have to remember, on average. Okay, how long does a person wait? So everybody has a different wait time, and that's what he's talking about, on average. Out of the 980 people, on average, that is it right there. Automatically find out where your total is and put that in your denominator. Okay, that's what you're doing. And when you do that, let's see, I want to say you get 700 without dividing this. The numerator is 760. The denominator, of course, is 980. That's the number of total people there. And then when you do that, you get something about 0.7755, or if you want to, about 0.776. Remember, you got to go at least 3 decimal point. If you go more than that, you're fine, but you can't go less than that. Alright, and of course the units are hours. And that's what you have to remember, on average. So on number 1, you had to figure out, you had to use this part right here. That's the rate that people were coming in. So on average, so you had to, if you look at that again, this is the rate. So what you would do is from 0 to 2, r at t dt. That is where this part right here is r at t. Alright, so that's that, and then you would have gotten 980 from the start, people. Alright, so people. Alright, this is asking how long. Alright, so the answer is going to be in hours. Okay. Alright, that is what you find there. Okay. Alright, so you had to get the correct integral, and it did say use the this part, use this one, so from the last problem. So when you use this one, then divide by 180. Alright, and then that's where you got your answer from. So that is an average. Okay, a lot of times you're looking for average velocity or something or whatever, average whatever you're looking for, and so average amount of time. You're going to do that. You're going to divide the whole thing by ever how many you found in the first place. Okay, and that is pretty much all I have for this one, and that's it. Alright, well, I will try to do some more videoing. My wife will be gone to get her a manicure and a pedicure, so I might have a little time to do another video. That would be the 2009 question 4, if you're interested. If you want to pull that up and look at that ahead of time and try to answer those, feel free to do that. That's what's going to be on my next lesson. This is the 117th lesson, and I'm very proud to be able to help you in that regard. And I do know that that test is coming around the corner. So being that I've been out for a little while, I don't know exactly when y'all take the test, but if it's been like it's ever been, it will be early May. Don't know that, so don't quote me on that. Those of you who are in regular calculus classes, toward the end of the semester, or term, or whatever y'all do, or quarter. Alright, well anyway, be that as it may, this is KP the Math G. Make sure you subscribe. I'm starting to get a few more subscribers. I get a few here and there, and like that trend to keep going if possible. And if you don't want to subscribe, that's okay. At least you're getting something out of this. Okay, understanding the phrases, the phraseology here, even from the last problem over here, understanding what total wait time is. Well, this is the derivative. This is a rate right here of the rate time, of the wait time. This is the rate of it, but this now, again, that rate now becomes total right here. Alright, so anyway, again, just start looking at things like that. That's what you're looking for here, and average, like we just showed a while ago. KP the Math G, make sure if you want to, I do like those likes. If you'd like to make a comment, please do so. I appreciate comments if you would like to do that. But if you'd like to subscribe, it would help a little bit for me. But this is not all about me. It's about you. KP the Math G signing off. My wife is probably waiting for me to do that signature clap, and I'm going to do that right now. Have a great day.